and now I'll get to chapter 18. I have the two reversed. So we wanted to see if the ratio 7 to 26 and 42 to 156 are equivalent. You could cross multiply and get 1092 on both sides. Or you can divide this one by 6 over 6 and show that they are equivalent. So if you divide by 6 over 6, you get a 7 here and probably a 26 down here. You go ahead and check it. So are they equivalent? Yes. Simplify the ratio 5 yards to 240 inches. Why ratio instead of rate? Because the units are the same type. You can convert yards into inches, and inches over inches drop out. So 5 yards is to 240 inches. As after you reduce, you divide by 5 over 5. 1 yard per 38 inches. 1 yard is the same as 3 feet. And a foot is the same as 12 inches. So 12 inches over 16 inches is like 3 over 4, and the inches don't have to be mentioned. So 5 yards is 240 inches, as 3 is to 4. You want to look at that for a few seconds? Then we wanted to simplify the rate, dollars per hours. Dollars cannot be converted to hours or vice versa. So we reduce by dividing numerator and denominator by 5. That gives us 123 over $7 per hour. The unit rate now, for unit you want the 1 here, so you divide numerator and denominator by 7. And 7 into 123 is apparently $70.57. So you get 17.57 cents per hour, per 1 hour. Unit means 1 in the denominator here. You could have said how many hours per dollar rather than dollars per hour, but that does not sound right. Can be done, but it's probably counterproductive. Now your spouse asks you to get toothpaste on your way home, and you have a choice of 5.8 ounces at $4.39 or 7.6 ounces at $4.99. Which of these two is the cheaper? Well, you divide both of these, the $4.39 per 5.8 ounces, divide by 5.8. You get about 75 cents, almost 76 cents per ounce here. And you divide 7.6 into 4.99, you get about 65 or 66 cents here. Which is a cheaper? This one, the 7.6 ounces. Hey, and we're done with that one. Okay, let's go over the solutions from last time. How many Caucasians are there at adverse CC? If the ratio is 56% and there are 15,000 students enrolled, the solution is there are 56 Caucasians per every 100 of all students, because 100 is percent, and that means X Caucasians are the 1,500. Note the units. Caucasians in the numerator, students in the denominator, or vice versa. You could have had students in the numerator, Caucasians in the denominator here, and here also. Now, be careful, if you don't have your units, it is possible that you get it backwards. Always keep your units. Did you hear me? Always keep your units. The units are user-friendly. Okay. So if you cross-multiply, or if you just multiply by 15,000, you come up with apparently 8,400. And then we wanted to reduce 15. Yeah, you can reduce that. We wanted to solve the following. So we cross-multiply. We get 5.6 times 0.9, which is 8 times x. I guess I should let you look at that for a while. Maybe you copied it. And notice that I am not multiplying 5.6 by 0.9, because maybe I can reduce and then I don't need to do this extra multiplication and extra division. I also didn't like the 2 decimals, so I multiplied by 100 over 100. Move one place here, 2 places here. And then 8 goes into 56 7 times. Then you have 63 over 100, so 0.63. X is 63 hundredths. Okay? 63 hundredths. You want to look at that for a little while? Not too long. Then we wanted to solve 2 3/4 over 11 is x over 8. Convert these two to improper fractions and multiply by 8. Improper fractions means 11 over 4 divided by 11. When you divide by 11 over 1, you multiply by 1 over 11. You cross multiply. This is 1 over 4, so this is probably a 2. Yeah, that's a 2. Why? Because 1 over 4 is 2 over 8. Pretty simple, if you know your math. Isn't math wonderful? Oh, you can play so many games with mathematics. It is so logical. It's amazing. It's absolutely fantastic what people who came before us have created. Estimate the travel budget for a vacation from New York to Quebec and back. Your car gets 26 miles per gallon. The one-way trip is 520 miles. And gas costs $4.39 per gallon. So what I wanted to do is set up a ratio, 520 miles over 1 to make it a fraction. Multiply by number of gallons per 26 miles. The miles drop out, you are left with gallons, which is wonderful. And then you multiply the gallons by dollars per gallon. Again, the gallons drop out. See what happens when you do units? That tells you the 4 is in the numerator. That tells you the 26 is in the denominator. Without you having to think. If the units work out properly, the numbers follow. And you end up with $87.80, which is about $90, multiplied by 2. I would budget about $120 for the travel portion of the trip. Get that? Users, units, units, units. Okay, I'm back. We want to do chapter 20, which is Introduction to Percent. And I want to tell you that we cover section 6.1, 6.2, and 6.3 in our textbook, and it all relates to percent. A percent is merely a simple ratio in which the 2-part, the denominator of the fractional form, is exactly 100. Before we start the lesson on percent, let's see something. Suppose you borrowed $847.23 for 1 year from Bank of Ripsville, and your friend borrowed $519.25 from Honest John. You are charged $61 interest, while your friend has to pay only $49.33. Which of you gets the better rate? Well, it's pretty difficult to answer this question, isn't it? Because we don't have the same base. We are not getting the same amount that we are borrowing. The amounts are different. But as I said, suppose that instead of having different amounts, we find out how much we pay in interest per $1. Divide 847.23 into 61, you get about 7.2 cents per dollar. And your friend, when you do the division of 519.24 over 49.33, gets about 9.5%. Not percent, per $1. Okay. So many cents in interest per dollar. So many cents in interest per dollar. Who gets a better rate? The $61. So you pay $7.20 per $100. that meant 77.2, what was it again? 7.2 cents per dollar. That means $7.20 per 100, while your friend pays about $9.50. And then we have a statement which came from this particular source on the internet, just to enliven things, just to make things a little bit more interesting for you, maybe a touch of history. In ancient Rome, long before the existence of the decimal system, computations were often made in fractional forms, which were multiples of 1 over 100. So they already used 100. For example, Augustus levied a tax of 1 over 100 on goods sold at auction, known as centesima ream venalium. Computation with these fractions was similar to computing percentages. As denominations of money grew in the Middle Ages, computations with the denominator of 100 became more standard, and from the last 15th century, the late 15th century, to the 16th century, it became common for arithmetic texts to include such computations. Many of these texts applied these methods to profit and loss, interest rates, and the rule of 3. I used the rule of 3 when I went to high school. I have not seen it used anywhere else in the United States, not yet. By the 17th century, it was standard to quote interest rates in hundreds. So that has a long tradition. And then let's come back to percent. Remember that of refers to multiplication in arithmetic, while per indicates division. And when I say per, I usually write it as a fraction, a horizontal fraction bar. Stay away from slashes. Why percent? Cent reminds us of 100. There are 100 cents in a dollar. There are 100 centimeters in a meter. How many feet in a centipede? Centipede sounds like 100 feet. But a fully equipped adult centipede can have anywhere from 15 to 177 pairs of legs. So 100 is in there. That comes from the internet also. Now, 5% can be written as 5 over 100. 5 times 1 over 100, 5 100, 5%. That's the percent sign. We wanted to show that 100% is 1. That comes in very handily. Replace 1 by 100%. The percent sign is in there. You just multiply by 100. You move 2 places to the right. I don't want to say that too loud, but you move 2 places to the right. All you have to do is remember right. Okay, that's 100 over 100, which is 1. Convert 1.2 to a percent, multiply by 100%, you get 120%, right here. Multiply 1.2 by 1. Convert 1.2% to a decimal, 1.2% times 1 over 100 percent. So 1.2 in the numerator here, percent. Divide by 100, move 2 places to the left. Convert 14 and 2/7% to a fraction. No decimals, okay? No decimals. A fraction. First, you want to convert 14 and 2/7 by saying 7 times 14 is 98 plus 2 is 100 over 7%, 100 over 7% per 100. The 100 drops out, you get 1 over 7. 1 over 7 is exactly 14 and 2/7%. Convert 5/3 to a percent and write as a mixed number. 5 over 3% times 100, you got the percent sign here. 500 over 3, 166 and 2/3%. Went a little too fast, okay. I'll let you look at it. You will probably get a hard copy of this. It should make it easier and more quickly for you to read it. And then I guess I am interested in giving you exercises. Show that 1000% is 10. Convert 21 to a percent. And then convert 21% to a decimal. So this was 21, this is 21%. Convert 77 and 79% to a fraction. Again, a fraction, not a decimal. And a fraction, so not a mixed number. 77 and 79%. Convert 76 to a percent and write as a mixed number. No decimals again. So write 7/6 as a percent and use a mixed number. Oh, that's the end of this part. Now we want to go to chapter 21, which says solving percent problems. I'll try to make this a 1 hour lecture rather than an hour and a half. So the basics, percent problems are often set up as a proportion. On the other hand, the following formula is extremely useful in dealing with percent. Okay. See how long you can remember this little formula. Amount is percent written as a decimal of base. The two key words is and of. Is stands for equal sign. Of is your normal multiplication. P sub d. Why sub d? Because I'm just using the letter P, but I want to remind myself to convert the percent to a decimal in this formula. As a ratio, sometimes they show you A is to B as P is to 100. The danger is if you're given the two numbers for A and B, which is in the numerator, which is in the denominator. We'll get to that shortly. Here, you don't have that problem. You have an is, you have an of, you have an equation, and you are given two of these three quantities. You solve for the other one. So amount is percent as a decimal of base. Is and of are two very useful keywords. As a reminder, 2.7, written as a percent, you can do this, or you can say 2.7 times 100%, and you'll get your answer immediately. You can bypass that. Or you can be given 2.7%, 2.7 per 100. Divide by 100, make the number smaller, go two places to the left. So 0.027, just as a reminder. I want to give you some examples. I'll give you three problems with the same numbers, 20 and 80, but in different positions, so the answers will be different. What is 20% of 80? The number that starts before the is not given, that's your unknown. This is given, convert to a decimal, 20/100.2 times 80. Amount is percent as a decimal of base. Amount is not given, is, so equals 0.2 times 80. A is 0.2 times 80. 2 times 80 is 160. Backtrack one decimal place, you got 16. So 16 is 20% of 80. Okay. I'll let you look at that very quickly. I can go on? Okay. 80 is 20% of what number? The number before the is given. The 20% is given. The number after the of is not given. So the number after the of, after the multiplication, is not given. And 20% is 0.2 as a decimal. Amount given as 80 is an equal sign, 0.2 times the unknown. Call your unknown b, call your unknown x if you want to. So 80 is 0.2x. Divide by 0.2. Ooh, how do we divide by a decimal? We don't. We convert the decimal to a whole number. So after I divide 80 by 0.2, I make it 800 over 2. 800 over 2, which is 400. Okay? So 80 is 20% of 400. $20 is what percent of 80? 20 is what percent, that's not given, times 80. So 20 equals P sub D times 80. 20 is unknown times 80. Divide both sides by 80, you get 2 over 8, 1 over 4, so 0.25 or 25%. Let's see what I just said. 20 equals, call it x if you want to, times 80. Divide both sides by 80 to make this 1 times the unknown. That's what you want, 1 times the unknown. And this becomes, when you reduce 2 over 8 or 1 over 4, you want this as a decimal converted to a percent. You could multiply by 25 over 25, that gives you 25 over 100, 25%. Or you can divide 4 into 1, you get 0.25. Multiply 0.25 by 100%. You don't need to do this, just multiply by 100%. You get 25%. So 20 is 25% of 80. So 3 problems with the same 3 numbers but in different positions. And the is and the of were key words. They kept me straight. Now you could also have used a ratio like I mentioned earlier. You can say P is to 100 as A is to B. The danger is when you're given A and B, like in the last problem, you may divide by the wrong numbers. You may get the reciprocal of what you need. If you remember that the B has an of with it, amount is percent of base, the of number goes in the denominator, you can keep yourself straight. There are 36 students in a class. 5 of those students have earned the grade of A. What percent of the class scored less than A? And round to the nearest tenth of a percent. Not tenth of a decimal, tenth of a percent. So 5 A's out of 36. 5 A students is what percent of 36? Okay. 5 is what percent of 36? 5 is what percent of, that should be 36, not 6, that's a misprint. Then you divide both sides by 36, you get 1 times x by itself, and you can't reduce that. So you get 36 into 500, which is supposed to be 13.9. And the 9 is probably a rounded number, so 13.9%. As I said, this is a misprint. That should be 36. Send me an email. Or when you write your homework and you turn it in, you can make a note. Okay, we wanted to know the percent of the class that scored less than an A. So if 13.9 students scored A out of 100, then 100% minus 13.9% is 86.1%. So 86.1% of the class scored less than an A. Then we have an interesting, useful application problem. You want to buy a house listed at $549,000. You need a 20% down payment. You have $95,000 in the bank for the down payment. How much more money do you need for your down payment? Or maybe you have enough, I don't know. We'll see. All right. So your house is $549,000. You need 20% of that. The down payment is 20% of the listing. The down payment is 20% of, so times 549,000, or 109,800. Too bad you can't use a calculator. But you want to train yourself to work with numbers. The numbers should start to make a little bit of sense. So you need 109,800. You have $95,000 in the bank. You are short $14,800. Okay. Of the total number of students at the university, 2,646 are graduate students. 79% of all the students are undergraduates. This number is not that number. Be careful. What is the total number of students at the university? Oh. The percent of graduates is 100, that's all students, minus the students who are not graduates. Okay. All students minus the not graduates gives you the percent of graduate students. So 21% are graduate. 29% means 2,646. The number of graduates is 20% of all students. The number of 20%, 21%, that's 0.21 of the number of graduates is 2,646. Divide both sides by 0.21. Multiply by 100 over 100. That's 264,600 over 21, which looks like 12,600. And that should be the total number of students at the university. A quick look. This is about 1/5. 1/5 of 12,000 is about, 2,500? That's about 2,500. That's a ballpark figure. It looks like our answers are, if not right, at least very close. And probably right. Hopefully right. Hopefully right. Okay. A retailer buys 20 pairs of shoes from a manufacturer. The retailer has expenses. He needs to travel, probably pay rent, utilities, taxes, and so on. To cover his or her expenses, the retailer adds a fraction of the cost of the pair of shoes to the cost when the pair is sold. This is profit, and the profit is used to pay the expenses. That fraction, usually a percent of the cost, is called markup. So you sell something, you sell it at a price for which you bought it plus your profit. So a percent of the cost of what you bought it for. Now suppose the shoes don't sell. Maybe the fashion changes, maybe the economy worsens, maybe the clientele migrates and so on. Whatever the reason is, the retailer has to get rid of those shoes. As an incentive to entice customers to buy the shoes, the retailer takes off a fraction, a percent, of the before discount price. That is the price at which the shoes sell after application of a discount. The discount is sometimes called a markdown. So you have cost, the markup, that gives you the sales price. Or you have the regular price, you want to get rid of it, minus the markdown, minus the discount, that's your sales price. So there are two ways of getting sales price. After you buy the shoes yourself, you want to sell them, that's markup. After you want to get rid of the shoes, you want a markdown or a discount of the regular price that didn't sell, that gives you the sales price. The phrase markup is percent of cost, emphasizes again the is and the of. Markup is percent of cost, and this will be beneficial. Now, the pet store buys 16 pairs of shoes at a cost of $27 each. The markup rate is 40%. The merchant wants to get 40% of $27 to add to that for selling. What was the markup and what was the sales price? Let S be the sales price. The cost is $27 and the markup rate is 40% or 0.04. So markup is percent of cost, or $10.8. And when you sell it, you want to add 10.8 to 27. 10.8 added to 27, which gives you $37.80. So you need to sell your shoes for $37.80, and you get $10.80 profit for your expenses. Note, markup is 0.04 for every dollar of cost. Then the sales price for every dollar would be $1 for cost plus 0.4 of markup, or $1.4 of the cost. We could have found the same sales price that we had up here, the $37.80, by multiplying the cost by 1.4. Check. 1.4 times 80 is 3780. And we had 3780 up here. Okay? Now, the pet store buys 16 pairs of shoes at a cost of $35. Each pair is on sale for $35. Find the markup rate. Well, first find, let X be the markup rate. The cost was $35, the sales price was $65, so the markup is the difference of the two, or $30. Markup, $30, is percent, which I don't know, of cost, that's $35. And if you divide both sides by 35, you get 6/7, which is X. And you want to convert that to a decimal. Looks like 0.8571. Percent is 85.7%. 85.7%. You want to round it to the nearest percent, so 86%. You want to check it, and yes, 1.86 times the cost is the sales price. Now the pet store sells a pair of shoes for $89.99. The markup rate is 25%. What was the cost of the pair? Now, what was the cost? The markup is 25% of cost. We are not giving the cost. We are giving the sales price. So we cannot take 25% of the sales price. That's a mistake lots of people do. And maybe you too if you're not careful. Let C be the cost. Okay, algebra. Let C be the cost. We know there's a number in a box. The number in the box is the cost. We have to find the key to open the box. Then the markup is 0.25 of cost, and the sales price is the cost plus the markup from here. And 1 plus 0.25 is 1.25 of cost. These two are like terms, so you can add the coefficients. Now your equation is 1.25 cost is $89.99. Divide both sides by 1.25. After you move the decimal point and do the division, you get $71.99, and you can round it to $72. So the cost must have been $72. You want to look at this for a little while. I want to keep this to 1 hour, so I got 20 minutes left and one chapter to go. A $159.99 regular price dress has been sitting in Elegante Fashion window for a year, and the merchant wants to apply a 15% discount. What is the sales price? Let S be the sales price. The discount is 15% of the regular price, the before discount price. The discount is discount rate of regular price. The rate of the regular price, that's $24 markdown. And when you subtract $24, you're left with $135.99. That's what your merchant wants to sell the dress in order to get rid of it. Now, the regular price of a hat was $34.99. It is discounted to sell by $27.99. What is the discount rate? What is the percent now? Let X be the discount rate. That's as a decimal. The discount was the sales price minus the discounted price, which is $7. That's the discount. And discount is percent of regular price. You divide both sides by 34.99, and you're supposed to get about 0.2 or 20%. You can take down these numbers quickly and work them out later. Gee, there are lots of examples here. Percent must be something quite useful, right? You'll find out someday. Find the regular price of a mattress that sells for $469.99 if the discount rate is 33.33. That's about 1/3. Let R be the regular price, then the discount price is 0.3333 after you convert this to a decimal, times R, and the sales price is the regular price is the sales price plus what you marked it down. So that's 0.3333 of R. So R minus 0.33 of R, you subtract this from both sides, gives you 0.6667 of the regular price. And that was supposed to be $469.99. Well, look at this and enjoy, because after we do the division, we divide both sides by 0.6667. We are left with 1 times the regular price, which should be higher than that amount. My guess is about 400, 230 times 3, about $700. Let's see how close we get. Yeah, $704.95. You can do quick estimating if you are proficient with the numbers. Like 0.66 something is about 2/3. 1/3 of this number is about 1/2 of this number is about 230, 240, and multiply by 3, 240 times 3, that's about 720, something like that. Oh, we have another example. A retailer buys a pair of boots for $200. The markup rate is 10% or $20. The sales price is $220. Okay. So you started with $200, you wanted to sell for $220. After a year you couldn't sell it, you take the $220, you take 10% of that and mark it down. So 10%, that's 0.1 of the sales price, which was $220, gives you $22 at a discount. You want to take $220 minus 22, and that means you have to sell it for $198, and you lost $2. So you don't want to lose, you want to take a smaller discount. Or getting $198 is better than getting nothing. So you take a $2 loss, at least you didn't lose $200. Now, the markup rate was 10% and the discount was 10%. You go up 10%, you come down 10%. Shouldn't that be the same thing? Shouldn't you have ended with 100? Well, think about it and let me know. Then you wanted a set of exercises. What is 20% of 80? 80 is 20% of what number? 20 is what percent of 80? There are 25 students in a class. 4 of those are earning the grade of A. What percent of the class scored less than an A? So 25 students, 4 of those scored an A. What percent scored less than an A? If you take shorthand, you can just write down the numbers quickly and some notes besides it. You want to buy a house listed at $629,000. You need a 20% discount. You have $105,000 in the bank. How much more money do you need to come up with? So value of the house, $629,000. You want 20% of that, and you only have $105,000. How much more money do you need? Of the total, there's a misprint here, of the total number of students at the university, 1,635 are graduate students. 85% of the total number is non-graduate. How many students are at the university? So 1,635 graduates, 85% non-graduates. At the Golden Nest, you buy a ring at a cost for $1,395. The markup rate is 65%. What is the markup and what is the sales price? $1,395 and 65% marked up. The Golden Nest buys a necklace at a cost of $235. It is on sale for $675. Find the markup rate as a percent and round to the nearest percent. So cost $265, sales $675, markup rate, that's for you to find out. Golden Nest sells a bracelet for $59.99. Markup rate 35%. What was the cost? Again, don't take 35% of the sales price. It's 35% of the cost. So $59.99 for sales price, 35% for the markup. What was the cost? $1,250 regular price. You want to give a discount of 33%. How much are you buying the computer for? $1,250, 33% off. Oh, and that's where we want to stop. No, we also have the regular price of a phone call is $89.99. It is discounted to sell for $67.99. What is the discount rate? Round to the nearest percent. So regular price before the discount, $89.99. After the discount, $67.99. And then find the regular price of a TV set that sells for $345. Sell for $345 if the discount is 21%. So what was the regular price before the discount? $345, 21%. Chapter 22, more on percent. First the basics. Hank takes care of toddlers in a daycare center. He was paid $21,450 a year and he got a $550 raise. Michelle was working for $32,750 a year and she got a raise for $700. Who got the higher percentage? Well, we have 100 times 550 over 21,450, which is 2.56%. We got 700 over 32,750, which is 2.14%. Okay? The increase over the original number, the year before the increase and the dollars before the increase. So this is a better higher, although the numbers are smaller, he gets a better percentage. Find the percent increase in the California population between the indicated years. Okay. This came from the Almanac. The percent increase in 1950, from 1900 to 1950, was 10.6 minus 1.5 over 1.5 times 100, was 673%. Let you look at it for a little while, maybe take notes. Okay, and from 1950 to 1990, we have 29.8 minus 10.6 over the original number 10.6 times 100, 181%. So 29.8 minus 10.6 over 10.6 times 100, 181%. From 1990 to 2000, 37.25 minus 29.8 over 29.8 times 100. So 37.25 minus 29.8 over 29.8, 25%. So a substantial decrease, a decrease of about 7 times. From 2000 to 2012, 38 minus 37.25 over 37.25 times 100, 38 minus 37.25 over 37.25, 2%. Gee, so less and less people apparently are coming to California, or maybe more and more are leaving. Okay, bye-bye. Okay, why was the increase from 1900 to 1950 so big? What happened in the years 1939 before 1945, which is probably before many of your ages? And why was the increase so small from 2000 to 2012? See if you can come up with some kind of reasonable conclusion. The percent decrease is defined similarly. The value of a house in 2005 was $254,000, and 5 years later it was $219,000. What was the percent decrease? Well, the decrease itself was $219,000 minus $254,000, or negative $35,000. $219,000 minus $254,000, so negative $35,000, a decrease of $35,000. When I say decrease, I don't have to mention the word minus, because decrease means we are going down. The percent decrease then was 35,000 over the original number in the year 2005, which was 254,000, and that quotient gives me 13.8%. Okay. Commission is the amount of money a salesperson gets as a percentage of what he or she sells. How much money does salesman Quick Sell earn if he sells a refrigerator for $1,250 and he earns 15% commission? Do you remember amount is percent as a decimal of base? Whenever you have a percent problem, if you can put it in the form of an is and an of, and two of the three quantities, amount, percent, or base, will drop in, and you can solve for the other one. So percent in this form is as a decimal. The commission is 0.15 times 1,250, which is supposed to be $187.50. That is the commission. So 15% of 1,250. Of means multiplication. Is an equal sign. That's the amount, 187.5. Now we come to something more interesting. Excuse me for a minute. Yeah, I got 22 minutes for this. A retailer buys boots for $90 a piece meaning a pair, not one of a pair. The retailer has to earn money to pay for expenses. This money is called markup, and it is a percent of the cost. The sales price then is a cost plus a markup. Okay? Suppose that markup on the boots is 40%. What is the sales price? Well, you want 40%, which is 0.4 of your cost of 90, which gives you $36. So 0.4 times 90 is 36. You add the $36 to the $90 to get your sales price of $126. The $36 is a markup, and it's used to pay for expenses, electricity, taxes, rent, employees, whatever. Now, you need to sell a lot of boots in order to make it, but that was a business you wanted to go into. A retailer has difficulty selling boots remaining unsold after 6 months at the regular price of $126 a pair, not a piece again. The retailer wants to give customers an incentive to buy the boots. He decides to sell the boots for less than the regular price, for less than $126. This decrease in money is called discount and is a percent of the regular price. Suppose that the discount on the boots is 40%. What is the sales price? 40% of the regular price, 0.4 times 126 is $50.40. That is my discount. That comes off of the $126, which means that after the subtraction, I'm left with $75.60. Isn't it interesting? I went up 40%. I went up 40% from 90. I went back down 40%, and I'm at 75.60, not 90. Ooh, how did that happen? So why is the figure of $75.60 less than the cost of $90? We had an increase, I just went over that, and you figured that out. We have another application of simple interest, not compound interest. And when you apply for a loan and you get a loan, interest is a reward for the bank or somebody who's lending you money to use the money so that you can use the money for a while instead of the person who's lending it to you. So the more you borrow, the more the reward is called interest. The higher the agreed upon annual or monthly rate is, the higher you get the reward, the more interest you get. One bank would lend you, would want $5 interest per $100 lent. Another bank might want $7. So that's the rate, that's negotiable. And the longer you have the money, the more the interest. And the rate is either monthly or annually, so the time must also be monthly or annually. The rate and the time must agree. Years, years, months, months. Okay. What is the interest on a loan of $2,500 at 25% annual rate for 30 months? Annual rate, 30 months. How much do you pay to retire the entire loan? In other words, to pay off the loan and the interest. Simple interest is principal times rate times time. The principal was $2,500, the rate was 25%. The time was 30 months, which is 2.5 years. The rate is in years, the time must be in years, which is supposed to be $1,562.50. You want to look at that for a few seconds? Then we are interested in retiring the loan. You need to pay the original money you borrowed, plus the reward, plus the interest. And I came out with $4,062.50. So the figure of 0.25 came from 25%. The 2.5 years came from the 30 months. That is simple interest. Compound interest, which is used in commerce, is more interesting. Interesting. Compound interest is more involved and is used commercially. If interest is compounded semi-annually, that means twice a year, which means every 6 months. Interest is added to the principal every 6 months. So at every compounding period, the interest that is earned in that period is added to the principal, and you need interest on a higher principal than you had before the interest. And I'll give you an example. We compound every 6 months. The original money that you borrow is $2,500, and we are back at 25%. Semi-annually, that means every 6 months, that means every half year, 1/2 is 0.5, the interest is computed. So for the first 6 months, it's principal times interest times time, which is $212.50. So if you only borrow this for 6 months, that's the interest. But now, for the next half year, for the second 6 months, your principal is no longer $2,500, but $2,500 plus the interest $312.50. So your principal for the second period is $2,812.50. And you take interest on that amount, $2,812.50, times 25%, times another 6 months, which is half a year. And when you carry out that multiplication, you're supposed to get $351.56, a little bit more than $312.50. Why more? Because you also pay interest on this amount. So we figured out the interest for the second 6 months. That interest is added to the previous principal, 2,812.5 plus the interest 351.56, which is supposed to be $3,164.06. That is the third 6 months period. Principal, this number right here, times rate times time, $395.51. So the first time it was $312.50, the second $351, and then $395. The interest keeps going up, much to the advantage of the person who is lending you the money. You have to pay back more. Fourth 6 months, the principal plus the interest. The new principal is $3,559.57. The interest is taken on that principal, so $3,559.57 times 0.25 times 0.5, $444.95, more than the previous $395.51. And after you copy that, I let you go to the last 6 months. You go ahead, you copy that. I think we have a few minutes left, like about 7-8 minutes. And I think I'm at the end of this example. So we are down to the last 6 months. The previous principal of $3,559.57 has $444.95 added to it. That's the principal at the beginning of the last 6 months. Here we go. That's 4,004.52. That number multiplied by 25%, multiplied by half a year, gives you $500.56. And what do you have to pay back? You have to pay back your original $2,500 plus this principal, to which you add $500, so about $4,500. There we go. Okay, that's the last interest. This was the previous principal. And when you add the two, you have to pay back this amount. Okay. How much more did you have to pay when computed with compound interest as when computed with simple interest? With compound interest, you have to pay back $4,505.08. Simple interest, you have to pay back $4,062.50. How much more do you have to pay in compound interest? $442.58. Isn't that amazing? Do you think that instead of compounding every 6 months, if we compound every day, we must get a heck of a lot more money because the interest is computed every day, 360 times a year as compared to semi-annually twice a year? Yes, you will get more, but there's a limit. Okay? The limit is, and you will learn that somewhere later in probably intermediate algebra, definitely in calculus, you will learn that the limit is, I don't know how to say it now, but there's a formula for it. That's continuous compounding. You compound bang, 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 bang. Okay, the effect of compounding interest is dramatic. Suppose you buy a house for $565,000. Your interest is 6.5% compounded monthly, and you want to pay it over 30 years. That means 360 months. 30 times 12 is 360. Suppose that the monthly payment is supposed to be $3,565 $71.18. Your bank wants you to pay this particular amount for 360 years. And the interest is eating up most of this. Only about $500 is used to deduct from your balance of $565, from $565,000. So you still owe almost everything that you borrowed. You give the bank almost $4,000, you still owe almost everything. How many years will it take you before you are down to half this amount, which is 2,800 something, 238,000 I mean. Not 15 years, 23 years. So you pay a lot of money for the first 23 years as compared to the last 7 years in which you pay the rest. Now, if instead of giving the bank $3,500, you give the bank $4,000. This extra $500 will be like canceling the last months, the 359th month, the 360th month is already paid for. And credit cards, the same thing. They want you to pay $15 a month. A small amount, like $2, is just used to reduce your principal. If you owe $300 after you give the bank or the merchant $15, you still owe, it was $300 originally, $298. So if you gave him $2 more, more than $15, the $2 would be like paying off a month at the end of the loan period. Think about that. Okay, exercises now. You can go to this link and you can get the population of the towns that I'm using here. The population of Atherton decreased from 7,194 in the year 2000 to 6,914 in the year 2010. What is the percent decrease? I got it from the almanac here. So 7,194 and 6,914. The population of Menlo Park increased from 30,785 in the year 2000 to 32,026 in the year 2010. 30,785, 32,026. What is the increase, and then what is the percent increase? Okay, that's your second problem. Your third problem: how much money does salesperson Bye earn if she sells a TV for $3,175 and she earns 12% commission? That's an expensive TV, isn't it? Okay. So $3,175 sales and 12% commission. A retailer buys a mattress for $2,800. Suppose that the markup is 50%. What is the sales price? So $2,800 and 50% for the markup. The markup rate. Okay, I should have said markup rate. That's a rate. And then you want to find the markup. Once you have the markup, you can get the sales price. Okay, I can go on. One more minute. A retailer has difficulty selling, so the regular price was $4,000. Well, that T shouldn't be there. $4,200, and the discount rate is discount rate, not discount. Discount rate is 50%. What is the sales price? So 50% of 4,200, no T. It's a discount problem. Simple interest. You borrow $5,200 at 20% for 18 months. How much do you have to pay back? So the interest plus the principal. $5,200 at 20%, 18 months. And then finally, what is the interest on a loan of $5,200 compounded at 20%? Compounded annually, no, compounded semi-annually for 18 months. It's like the example I showed you with the 2.5 years and compounding semi-annually. And I think that's it.